about the polar plot for type 2 system. So type 2 system. Type 2 system, let us consider the type 2 system like 1 by s square into 1 plus 2s. Say, as there are you see two poles at s is equal to 0, that means this is a type 2 system. Now in order to have the polar plot, the same procedure for the previous classes we will follow. That means put s is equal to j omega, that means frequency domain transfer function g j omega will be equal to 1 by j omega square 1 plus 2j omega. Now j square, again that is minus 1, so we can write like j square is equal to minus 1, so this is minus of omega square 1 plus 2j omega. So that is equal to, you may write it minus of 1 by omega square 1 plus j of 2 omega. Now in order to get the imaginary free denominator, we have to adopt the same way, that means minus 1 into 1 minus j 2 omega. That means you have to multiply the numerator and denominator with the complex conjugate of 1 plus j 2 omega. So this is omega square, and you see that is 1 plus j 2 omega into 1 minus j 2 omega. So that equal to minus 1 plus j 2 omega by omega square into 1 plus 4 omega square, right? So now this j omega can be written like in real plus imaginary. So you separate out the real and imaginary part to get minus of 1 by omega square 1 plus 4 omega square plus of j 2 omega by omega square 1 plus 4 omega square. Now after simplification, you may write it minus 1 by omega square 1 plus 4 of omega square plus j of 2 by omega into 1 plus 4 omega square. Now this is our j omega. So j omega equal to minus of 1 by omega square 1 plus 4 omega square plus j of 2 by omega into 1 plus 4 omega square. Now at omega equal to 0, gj0, this is equal to minus 1 by 0, 1 plus 4 into 0 plus j into 2 by 0, 1 plus 4 into 0. That means 1 by 0 into 1 plus 0 plus j 2 by 0 into 1 plus 0. That is 1 by 0 into 1 plus j of 2 by 0 into 1. That is, you see, this is minus 1 by 0 plus j of 2 by 0. That is minus infinity plus j of infinity. Right. So what you get at omega is equal to 0, you get the j omega equal to minus infinity plus j infinity. Magnitude of j omega will be equal to then infinity, and angle of j omega equal to 90 degrees. Now this is minus infinity plus j of infinity. That means the quadrant will be equal to, this is minus and plus, that means minus and plus. So this is a second quadrant operation, right? So similarly we can get the value of j omega at omega is equal to infinity. Now analysis will be same for the, so you see j of infinity, that means at omega is equal to infinity, but you will get equal to this is your function. So minus infinity 1 plus 4 into infinity plus j of 2y infinity 1 plus 4 into infinity. So that becomes minus of infinity 1 plus infinity plus j of 2y infinity 1 plus infinity. That means minus 1 by infinity plus j 2y infinity. So that is equal to minus 1 by infinity, that means 0, plus j of 0 2 by infinity. So you see g of j infinity, that means at omega is equal to infinite, you get j infinity equal to minus 0 plus j0. So minus 0 plus j0, again this is a second quadrant operation. And magnitude of g infinity, jg infinity equal to 0, and angle of gj infinity equal to your 90 degrees. Actually there is a mistake previously when we have calculated j0. So magnitude was infinity, but angle should be j0, that was 180 degree. You will just go to the previous slide or previous just backward of this lecture, backward direction. You see I have written previously, that is j of g0, that has been written as 90 degree, but it will be 180 degree. So this geo magnitude is infinity, angle is 180 degree, and this is a quadrant, this is second quadrant. Similarly, you see gj infinity, magnitude is 0, angle is 90 degree, that is also second quadrant operation. Right, now you can draw the polar plot by using these two equations or two set of values. Drawing of the polar plot for type 2. So type 2 system we have analyzed. Now we are going to draw the polar plot. So this is your real axis, this is your imaginary axis, and initial value, that means at omega is equal to 0, what is the value of